we have to share the YouTube link in our chat so that those who are waiting, they can see in our YouTube channel, right? So the meet room is now full.
Didi, link to share korte bolo Orupke.
Orup or Debuda, you can just share the YouTube link in the chat message of this chat room of Google Meet.
Didi, poster টিকে আরেকবার অন করব?
হ্যাঁ, poster on করে রাখো. Share the poster up till 11:59, okay?
Okay. Didi 101 দেখাচ্ছে।
Okay, if you can join, if you can take in people, you take in. If you can, then you can take it. Okay. You take Shuranjana Bhadra if she is still there. I just saw.
There is no option.
$101 it's showing.
কত লাগবে দেখে হিসেব করে আনো। অন্তরাদি,
হ্যাঁ
এবার আমরা রেডি করবো। 58 হয়ে গেছে।
Poster, stop sharing the poster and requesting everyone to mute themselves,
ওকে
including
ওকে
host, including everybody, to mute themselves. We will go live in 2 minutes.
Dr. Shayantan Sarkar, welcome. She has joined. He has joined.
Thank you. Thank you.
ওয়েলকাম স্যার।
Thank you.
ওয়েলকাম ডক্টর সরকার।
Thank you.
So am I audible to everybody?
Yes, ma'am.
Yes, you
Yes,
are.
ma'am. Yes, ma'am.
Okay.
Already you are.
Okay, thank you. So in less than a minute, we should start.
Antara, our principal ma'am has joined, isn't it?
She has joined.
Okay.
So requesting everybody to mute themselves as we begin our journey for today's session. Good afternoon, everybody. All gifts are off. For this stolen spark of power, the world rebelled and asked for something back. He cheated. Men enjoyed playing with fire too much, thought little of him on his rock, consumed and chained. The air grew hot and dark. These lines from Oliver Tyrrell's poem, Earth Summit, which were written early this year, use the myth of Pandora's box to discuss climate change. Understandably, the poet here is weaving in the myth of Prometheus, the one who, in a sense, gave man his first technological capacities by stealing fire from the gods and giving it up to the humans. As we wrestle with the burning issue of climate change and try to gauge its impact on our environment, this poem, I feel, is a reminder that once the ills are out of our jar or the Pandora's box, it is difficult, it is hard to put them back in once again. In today's webinar, we are going to undertake a scientific journey through the root of climate change. We are going to understand the myth and unfold the reality behind the global climate change. So without any further delay, I hand over this virtual space to our respected principal, Dr. Saida Sarikatul Mola Al-Qadri, and asked her to deliver her welcome address. I want to tell the viewers that Madam is facing a terrible network issue, so she will keep her video off and would address the entire virtual space over here in Google Meet and in the YouTube through her voice. Over to you, Madam.
Respected Dr. Shantanu Sarkar, Dr. Devaprasad Banerjee, IQAC Coordinator, Dr. Shampa Sen, Secretary, Teachers Council, Government Girls General Degree College, my colleagues and my dear students. It gives me immense pleasure to extend a very warm welcome to all of you in this one-day national webinar on global climate change, responses and resolutions, organized by IQAC in collaboration with Seminar Subcommittee of Government Girls General Degree College, Iqbalpur. Climate change is one of the most important issues which we are facing today. It is affecting every country on every continent. Due to the change of weather pattern, natural calamities are becoming more and more frequent. It is disrupting national economies and affecting lives. According to the report of World Meteorological Organization, WMO, there is an increase in the concentration of greenhouse gases, due to which the temperature of land and ocean are rising. Sea level are rising, glaciers are melting. It also highlights impact on socio-economic development, migration and displacement, food scarcity, and land and marine ecosystems. Climate change is impacting human lives in various ways. According to the International Federation of Red Cross, more than 50 million people were affected by natural disasters such as flood, drought, and storms in 2020. According to FAO and WFP, between the years 2008 and 2018, the agricultural sectors of various developing countries had to face a severe damage of over 108 billion US dollars due to lost crops and problems of livestock production. Nearly 690 million people, or 9% of the world population, were undernourished, and about 750 million, or nearly 10%, were exposed to severe level of food insecurity in 2019. The response to climate change, citizens in advanced economies are willing to change their lifestyle. A survey in 17 cities of North America, Europe, and Asia Pacific region finds that the people are concerned about the personal impact of global climate change. And across all 17 cities, people are willing to consider a lot of changes to daily life as a response to climate change. Not only the citizens of different countries, but also global organizations like the UN are trying to solve this problem. On 19 April 2021, UN Secretary General said in a press conference in New York that we have no time to waste. The climate is changing and the impacts are already too costly for people and the planet. This is the year for action, and countries need to act to protect people against the distress effects of climate change, disastrous effect of climate change. UN has taken a resolution to affirm the importance of educational programs to raise awareness of climate change and its relevance to the global population. Governments around the world have spent considerable time and effort in recent years to develop plans to make a safer and more sustainable futures for their citizens. Saving lives and livelihoods requires urgent action to address both the pandemic and the climate emergency. For making a change, we all need to work together. I hope today's webinar will enlighten us about the responses and resolutions of global climate change. Thank you.
Thank you very much, madam. That has set the tune for the day. This webinar was conceived and executed under the able leadership of our IQAC coordinator, Dr. Debaprasad Banerjee, who is also the head of department English at the Government Girls General Degree College, Iqbalpur, Kolkata. Now, I request Dr. Banerjee to share his thoughts on today's webinar. Over to you, Dr. Banerjee.
Yes, very good afternoon, everyone, and very warm welcome to today's speaker, Dr. Sayantan Sarkar from IIT Mandi. We are really grateful to him that he has made it convenient to attend today's webinar and address us. Principal of the college, Dr. Sharikatul Molla Al-Qadri, Teachers Council Secretary, Dr. Shampa Sen, our IQAC members, Mr. Ashish Ghosh, JDPI, Government of West Bengal, Muhammad Abu Nasir, Advocate, other members of this college, teachers of this college, and seminar committee members, Dr. Antara Mukherjee, Dr. Koel Odhikari, Professor Abdul Motin, and our technical experts and teachers of our college, Dr. Rajashri Dasgupta, Dr. Shabnam Parveen, office staff of our college, Pratul Babu, Arup, without whose help nothing could be done. They have been working for the last few days, day and night. Office staff, library staff, students for whom we have, and of this college and from other colleges. I also very warmly welcome teachers, other guests from other colleges and principals who have shown our keen interest in our program. We hope to get their cooperation in future, and we have been eagerly waiting for Dr. Sarkar's talk today. So with this, I thank everyone for joining today's webinar. We hope to get your cooperation in future. Thank you, everyone.
Thank you, Dr. Banerjee. Indeed, this has been a team effort, no doubt about it. Faculty members at Government Girls General Degree College are extremely fortunate to have an understanding and supportive Teachers Council Secretary in Dr. Shampar Sen. She is an associate professor of Bengali, and she has been extremely encouraging in putting up whatever we could in today's webinar. So it's time to hear from Dr. Sen. Over to you.
Thank you, Antara. Good afternoon. Thank you to each and every one of you for being here with us today. It is a moment of extreme pleasure to welcome our distinguished guest, our resource person of today's webinar, Dr. Sayantan Sarkar, an assistant professor of IIT Mandi. He has a brilliant career. On behalf of our institution, I offer my regards to him. I'm lucky enough that he is a guest today. I'd like to thank and offer my regards to our principal, Dr. SSM Al-Qadri, for encouraging us always. I'd like to thank our great convener of IQAC, Dr. Debuprasad Banerjee, and all his team members. I'd also like to offer my regards to all the teachers member of seminar subcommittee, particularly Dr. Antara Mukherjee, our convener, Dr. Shabnam Parveen, Professor Abdul Matin Wasim, Dr. Quail Odhikari, Dr. Rajashri Dashgupta, and our office staff, Arup Ghosh, who made this webinar functional in such hard times. The topic of today's webinar is very interesting, and basically it's a burning issue, we know. We are all waiting for the lecture of eminent resource person. Here I welcome again all respected teachers, our office staffs, faculty members, beloved students, and all distinguished guests from other colleges on behalf of our institution. Thank you all.
Thank you so much, Dr. Sen. Now it's time, rather it's my privilege, to formally introduce our resource person to our viewers, both.
Antara, you have got muted.
You got
Antara, you have
muted.
got muted.
I'm so sorry. I'm so sorry.
Yeah.
Thank you, Dr. Sen. Now it's time to officially introduce our resource person, Dr. Sayantan Sarkar, to our viewers, both in Google Meet and in the YouTube platform. Dr. Sayantan Sarkar, as Dr. Sen has mentioned, is an assistant professor in the School of Engineering, Indian Institute of Technology, Mandi. He has specialized in studying the effects of aerosols on air quality, climate, and human health. He has a PhD degree from Jawaharlal Nehru University, and he has held postdoctoral research position at Wordsworth Center, New York State Department of Health, and at the National University of Singapore. Prior to joining IIT Mandi, Dr. Sarkar worked as an assistant professor in the Department of Earth Sciences, IISER, Kolkata. As a part of the Indian Arctic expedition, Dr. Sarkar has studied the effects of aerosols on polar climates, and he is currently involved in a similar research project focusing on the Himalayas. We are once again thankful to him for his time and for accepting our invitation to deliver his talk entitled The Journey from Myth to Reality and the Science Behind Global Climate Change. With these few words, I hand over this virtual space to Dr. Sarkar and request him to begin his deliberation. Over to you, Dr. Sarkar.
Thank you, Dr. Mukherjee. So am I audible?
Yes. Yes.
Yes, sir.
Okay. So a very good afternoon to all of you. First of all, I'd like to thank Dr. Al-Qadri, all the faculty members and the staff of Government Girls General Degree College in Kolkata for kindly extending this invitation to me and allowing me the opportunity to come here and present some of my thoughts to you. I think the introduction given by Dr. Mukherjee and also by Dr. Al-Qadri were especially important, and they set the stage for what I'm about to say, and it makes my job a little bit easier. And that was a wonderful and very comprehensive and precise introduction about what climate change is and what are the effects that we are currently facing. So let me just share my screen because I will have slides to share. Okay, so is the slide visible?
Yes.
Okay, all right.
Could you just make it full screen?
Yeah.
Yes, perfect.
Okay, so I'll deliver the talk in English, and whenever if you have questions later on, we can discuss them in any language we want. We can Bengali, Hindi, English, that depends on the choices. So I'm going to talk about climate change, myths, reality, and the science behind it. So climate change is a vast subject, and it's not possible to do justice to it in a short presentation such as this. So what I've tried to do is that I've tried to pick up one aspect of it, which is basically the myth aspect of climate change, the misconceptions that exist in society regarding climate change. And I'll try to show that how these myths are actually false and what is the actual reality that's behind it. Now, these three sort of cartoons that are there on the slide, they try and showcase what I'm going to talk about. So currently, as we all know, that we are going through this incredibly terrible pandemic situation, and we are currently facing this sort of wave of COVID-19. So that what it does is that sort of obscures our vision towards far more distant but equally dangerous problems that are looming in the background. So while we are trying to deal with COVID, we are not sort of trying to actively deal with the recession that generally comes with lockdowns associated with COVID. And then we have this other issue that is burning in the background, this climate change problem that is not going away anywhere, and it's still there. But we have sort of diverted our vision from this problem and then trying to solve this clear and present danger that we have at this moment. Now, while climate change remains in the background and does the thing that it does, our response to climate change can be generally of two types. Either we can embrace the scientific evidence there is for climate change and we can act accordingly, we can make policy accordingly, or we can do as some climate change deniers do, that we can say that it's all a hoax, it's a conspiracy by scientists, there is no climate change. And when presented with evidence of climate change, we can say that, okay, I understand, but it's very costly to do anything about it. We can't mitigate climate change because it's very costly. If then these people are given options, cost-efficient options to do something about it, then they will say that it's late to do anything. It's already too late to do anything. Now, this is actually quite true because the more time we spend not doing anything, the more we go towards this sort of catastrophic destruction of the Earth system because of what climate change can do to us. So what we'll do is I'll try to focus on this part today. I'll talk about why do certain people think that climate change is a hoax? Why do people think that it's a conspiracy? Why do people think that it's something that does not really exist? And what science tells us and how it proves these conceptions wrong. Now, the good thing about any natural law, and climate change is a natural fact, is that it remains true whether or not we believe it or not. Okay, so irrespective of our belief in that, it remains true. That's a good thing about science. So with this, let us start. So the first question that we ask is that, what do people think regarding climate change? Do people really think that climate change is happening? And do people really think that humans are responsible for climate change? So there have been large-scale opinion polls that have been conducted across the world, and people have been asked these questions that, do you think climate change is real? And do you think humans are causing it? Now, people have responded in different ways depending upon which country they live in. So if we look at this sort of question, where the population was asked that, do you have a basic knowledge about global warming? Do you know what global warming is? Do you know what climate change is? Then the people have responded in this manner. So the darker colors indicate greater understanding of global warming. So for example, developed nations, for example, the United States here, majority of the people said that yes, they have a good understanding of climate change and global warming. Australia, for example, most people say that they have a good understanding. European nations here have a good understanding. India is somewhere here in the middle. So our population has a generally moderate understanding of global warming. Now the problem is that when this same set of people are asked a separate question, that how many of you believe that humans are causing global warming or climate change, then we come to some interesting results. So the US, which basically said that it knows a lot about global warming, only a small fraction of the people actually believe that climate change is being caused by humans. Okay. On the other hand, India remains moderate at this point of time. Okay. So the problem is that developed countries like US, although they profess a great knowledge about climate change or global warming, at the same time, they don't believe, most of them believe that it's being caused by humans. So why is that? And this is quite a dangerous trend, because ultimately remember that our actions towards mitigation of climate change can come from national governments, can come from corporations, can also come from individuals like us. So unless we acknowledge that there is a problem, then we are very unlikely to do something about it. So the first step in solving the problem is to acknowledge it. So many people here are not acknowledging the problem. So you can basically categorize these people into three categories. So one is the people that deny the trends. For example, the way we know that climate change is happening is because we have records of temperature increasing over time for the last century. We have measurements of temperature throughout the world, and these temperature values are increasing over time. So these people will say that I don't believe that temperature trend. That's a conspiracy. Scientists are in a conspiracy to prove that climate change is happening, and therefore they're deliberately modifying the data. Right? They are falsifying the data. So these people are trend deniers. Okay. There is another category of people who will say that, okay, I believe the temperature trend. I understand that climate change is happening, but what I don't agree with is that climate change is being caused by humans. So the attribution of climate change to human activities, that part, they do not agree with. They don't believe that. These are attribution deniers. And there's a third category of people who will say that, okay, I understand that the trends are increasing, it's being caused by humans, but the negative effects of climate change, I don't believe that. I think climate change is good. So there are three categories of people, and we need to be aware of these three categories of people. At the same time, there's this other sort of phenomenon that is coming up where it's said that climate change is just a theory. It's not something that is proved, it's a theory. And the problem here is that the word theory, when used in a vernacular context, has one meaning. And when it is used in a scientific context, it has a completely different meaning. In science, a theory is something that has been proven with experiments. So the theory of evolution is a theory. The theory of gravity is a theory. So none of us would try to test the theory of gravity by jumping out of a 10th floor window, right? So we know that theory of gravity is true. So that way, climate change is also a theory, which means that it's a scientific fact. So you cannot basically dismiss the problem simply by saying that it's just a theory. Okay. Now, before we go into what the myths are regarding climate change, let us very briefly go through what is climate change. So I'll not go into too much detail regarding the science of it. So if you have specific questions, we can discuss in detail regarding how climate change is really happening. But just to give ourselves a brief introduction regarding what climate change is. So climate, as you know, is different from weather. So weather is sort of the day-to-day variations in meteorological parameters, the temperature, the rainfall, and climate is a long-term average of that weather. So weather is something that you get and climate is something that you expect. So you can say that Januaries will be cold. So that's climate. And the temperature of, let's say, 3rd January 2021 being 17 degrees Celsius, that is the weather, right? So weather is sort of the mood, climate is the personality. That way you can put it. So climate change is basically the change in parameters of this change in the climatic parameters, meteorology, temperature, rainfall, and associated weather parameters. How frequent are storms? How frequent are floods, drought conditions? How these parameters change over time. So these are generally averaged over very long periods of time, and they are interchangeably termed with global warming. So global warming is basically the increase in global average temperature since the industrial age. So industrial age would be 1850 onwards, when there was large-scale industrialization in Western countries, US, UK, and other places. So we consider that to be a starting point of large-scale human activities, and the effects that the next 150 years has had on the global average temperature increase, that is called global warming. Now, I have underlined average here because it's important to understand that when we talk about climate change, when we talk about global warming, we are essentially talking about average temperatures. Average temperature increasing will mean that there will be certain places on Earth which will heat up at a faster rate as compared to other places. There might be certain places of Earth which might cool down as well, but the average itself goes up. So this is what it's important. So how does climate change happen? This is quite a simple explanation of what happens. So you have the solar radiation coming in. The Earth absorbs the solar radiation, which is mostly in the visible wavelength, the visible light that we see, and then it emits the light at a different wavelength. It emits it at a higher wavelength. So this is called terrestrial radiation, and it's emitting in the infrared wavelength. So infrared is something like heat sensors. So if this is an aircraft and it's flying, so as you can see, the engines are sort of colored up because the engines are emitting heat. So wherever you have heat emission, you can sort of map it using this infrared sensors. So the Earth is basically emitting radiation in this infrared range. The problem is that there are certain gases in the atmosphere which are called greenhouse gases, and there are certain particles in the atmosphere that absorb some of this infrared radiation that is trying to get out of the atmosphere. So if you have the energy staying within the atmosphere, then the system will heat up. If the energy is able to leave the atmosphere, then the system will cool down. So what these gases and particles do is that they absorb some of this infrared radiation, and as a result, the radiation sort of continues to bounce within this atmospheric system. It is not able to go out of the system. As a result, it warms up. Now, the greater the amount of greenhouse gases, the greater is the warming. You have 1 kilogram of carbon dioxide, it will absorb some amount of radiation. If you have 10 kilograms of carbon dioxide, it will absorb much more radiation. So it's proportional to the amount of the gases that is present. So the greater amount of gases we emit into the atmosphere, the greenhouse gases, the greater will be the warming. And this warming is the initial input that drives the change in weather and climate. This is the sort of factor that forces everything else. This is the initial condition which drives the rise in temperature, which drives changes in the rainfall precipitation patterns, floods, drought conditions, so on and so forth. Okay. Now let us come to the myths. So with this understanding, we'll talk about the most important myths that are there regarding climate change. Now, the thing about climate change is that all of us have some understanding of climate change. So if you ask a general member of the public that what is their understanding of climate change as compared to, let's say, quantum physics, their understanding of climate change would be much better than their understanding of quantum physics. So we have some understanding. We read about it in the newspapers, we hear the news, we see it on social media. So we have formed some opinion about climate change. The problem is that in many cases, this little knowledge that we have can be misguided. There are forces that are there that will sort of misguide public opinion on climate change because there are vested interests. So let us try to see what these myths are and then try to break them down. The first myth is that climate change is caused simply by the sun. The increase in temperature that we are seeing now is simply because the sun is getting brighter. It's because of changes in solar activity. Now, the problem is that this statement is partially true because the sun's brightness actually changes. It fluctuates over long periods of time. So there are generally two modes of fluctuation. One happens over timescales of, let's say, 100,000 years. So it's a cycle that sort of repeats itself every 100,000 years. And then there's a smaller cycle that repeats itself in, let's say, 11 years. But the problem is that the amount of change in temperature that we can derive only from changes in the solar output are simply not large enough to cause the temperature change that we are seeing now. The temperature change that we are seeing currently cannot be explained by the variability of the sun. The sun might be it's a tiny component of climate change, but it's not a significant component. Okay. So that's one myth. The second myth is that the carbon dioxide levels that are present in the atmosphere, they are too small to cause any damage. We know that the atmosphere, the air is 78% nitrogen. So that means every 100 molecules of air, there are 78 molecules of nitrogen. Carbon dioxide concentrations are about 410 parts per million. So for every million molecules of air, there are only 410 molecules of carbon dioxide. So it's present in tiny amounts. So some people say that if a gas is present in such small amounts, why would it be able to cause some damage? But this is again a misconception because we see this example all around us that chemicals that are present in tiny quantities can indeed cause damage. So arsenic, for example, is a very highly toxic and carcinogenic chemical. If you intake arsenic in tiny quantities, in the amount of nanograms, let's say 10 to the power minus 9 grams, for a long time, it will cause health problems as significant as cancer. So chemicals like this, it does not matter that their concentrations are very, very small. It's not small enough to not cause any problems. So if you look at the temperature trend here over time, which is the black line here, and the carbon dioxide trend over time, which is the red line here, you see they follow each other very nicely, which means that carbon dioxide increase is indeed driving temperature increase. So this is very good proof that the amount of carbon dioxide is not insignificant. It is in fact driving climate change. The third statement that is given, the phrase that is used is that the jury is still out. This is generally used in the US, where people say that the jury is still out on climate change. What they basically mean is that science has not decided whether climate change is still happening, and science has not decided so far that whether it's being caused by human activities. Now, this is a flat out lie because there have been thousands and thousands of scientific studies done on various aspects of climate change. There have been studies that have looked at these 1,000 studies and seen what are the major conclusions. So, for example, this document, it quantifies the consensus on anthropogenic global warming. It has found that out of the tens and thousands of studies that have been published on climate change, 97% of them clearly say that climate change is happening and humans are causing it. So this statement that science has not reached a consensus yet is a complete lie. And anybody who tells you that, you have to call them out for it. The fourth myth is that it's cold today. People will say, oh, the winter this year was very cold. Then how can climate change be happening, right? This year we got more snowfall than last year. How can climate change be happening and how can global warming be happening? But we have to understand, this is what I said in the last slide, is that global warming is the increase in the average temperature. It does not mean that temperature at all points across the globe will increase at the same rate. There will still be winters, but the problem is that winters all across the world are getting warmer. So nowadays, if you look at it from an average point of view, winters are becoming more and more warm. That is what global warming does. It does not mean that there will be no winters. It does not mean that there will be no snowfall. There have been ridiculous cases like a United States senator once came to the United States Senate holding a snowball in his hand, and he sort of lifted it up to the camera and said that, see, I have a snowball, how can global warming be true? So that's a ridiculous statement because, yes, there will be snow. But the point is that overall, if you see, the planet is warming. So whether there is snow in one winter or whether one day is colder than the other has no impact whatsoever on whether climate change is true or not. Now, the fifth is that climate change is natural and it has always been happening. So this is actually a correct statement that climate change has a significant natural component. But the problem is, like the sun, the natural factors that affect climate change are also not significant enough to drive the temperature rise like we are seeing now. Okay? Natural factors do affect climate. We will take a look at it quite soon, but they are not very significant. They cause very small fluctuations in climate, not very large fluctuations. This understanding that the temperature record is falsified, so I've already talked about the trend denial, so this is basically that. Now there is something called the pause, which basically means that when you take a look at the 100-year data set of temperature across the world, you find that there are places, there are times, 5-6 years, in which the temperature is more or less stable. It's not increasing. So sometimes people point to that part and say that, okay, for these 5 years, temperature was not rising. So how can there be global warming? So this is what happens when you cherry pick data. So an example is this. So if you look at the red part, right? So if you look at these 5 years, they are pretty stable. But if you put it in context of the entire 100-year time series, you find this entire trend going up like this. So once you squeeze the 5 years, then you find this entire trend going up like this. So this is just a fluctuation in an overall trend. Okay. So temperatures remaining constant or temperatures even decreasing for 3, 4, 5 years is not an indication that climate change is not happening. It's simply because all of this is part of a large scale time, hundreds of years where temperature are consistently increasing with small fluctuations in between. The other myth is that climate models are not accurate. Now, climate models were not accurate in the 1970s. In the 2020s now, they are extremely accurate. So for example, if you compare the model data, which are the red and the blue lines of temperature, and the measured data from the thermometers that are placed across the world, you can see that they more or less match. So the models are being able to predict temperatures very, very well. So they're being able to predict what is going to happen to the climate very, very well. So models not being accurate might have been a valid point in the 1970s. They are not a valid point now. And the last point is that global warming is good. That global warming will lead to increased temperatures in, let's say, polar regions or temperate countries, more agriculture, more food production. But that's a very silly thing to say, because if there is temperature increase in temperate regions, let's say around the Europe and US, there will be far greater temperature increase in the tropical regions. So there will be tremendous amounts of drought. People will lose their livelihoods. They will lose lives. So just because it drives agriculture in one part of the world does not mean that climate change overall is a good thing. So these are the most common and persistent myths about climate change. Now let us look at what is the reality. The reality is that if you take a look at temperature data for the past 2000 years, this is how it changes. So the blue colors mean that the temperature is colder. The reddish ones mean that the temperature is warmer. So if you look at this 200-year record of temperature, 2000-year record of temperature, we can sort of derive two conclusions from this figure. One is that after the 1950s, you see that the extremely dark red, so the temperatures here are extremely, extremely high. The first conclusion is that the period after the 1950s is the hottest period in the entire 2000-year-old record. So this sort of dark red is not found anywhere here. So the temperature increase that we are seeing over the last 50 years is unprecedented in the last 2000-year history. So then an associated question is, how do we know about global temperatures from 2000 years? Thermometers did not exist before. Okay. So thermometers did not exist before, let's say, 1800s. So there were no temperature measurements in the 9th century or the 7th century or the 1st century. So how do we know what the temperatures were? How can we draw this plot? So this is one question that I'll try to answer in the next slide. The second thing is, as you can see that there are certain oscillations in temperature. You see that there are blue lines and there are certain red lines, blue lines and red lines, which means that in the Earth's history, there have been periods where the climate is warmer, then colder, then warmer, then colder, like this. Now, this part cannot be due to human activities because humans started burning coal and petrol and diesel only around this point of time. Here, no large-scale coal combustion or cars or diesel fuel use, gasoline use, nothing was there. So only natural factors were there, right? So whatever variations or fluctuations we see here must have been caused by natural factors. So the question is that if climate fluctuates naturally, as we can see from here, how can we be sure that this is being caused by human activities? This can also be part of the natural fluctuation, right? So these are two questions that I'll try to answer in the next couple of slides. So the first question is, how do we know about historical temperatures? How do we know what the temperature of the Earth was 2000 years back, or maybe 100,000 years back, or maybe 1 million years back? How do we know this? To answer this question, if you ask a historian that how do we know about, let's say, Mughal history, or about Victorian England, or about Egypt during the time of the pharaohs, okay, how do we know about these things? None of us were alive during these periods. How can we reconstruct history for periods that have gone by? So what historians would do is that they would go to libraries, they would go to archives, and they would read documents from these periods that were written in these periods that describe the period. And then from multiple documents, they will take information and then create a likely portrait of these times based on that evidence, right? So historians would go back to libraries, archaeologists will go back to their digging sites and dig out the old remnants of the civilizations, and that is how you create the history where you were not there. So what do scientists do when we want to know the history of climate change? So just as a historian goes to libraries, scientists go to natural libraries. So natural libraries are these lakes and remote ocean sediments, the polar ice caps, the glaciers that are present. So why am I calling them natural libraries? I'm calling them libraries because what happens in polar regions is that over time, water condenses into ice and it gets deposited in layers. So let's say in 1000 AD, there was one layer of ice. In 1050, another layer came down. 1100, another layer came down. Then over time, this ice builds up as an amalgamation of layers. So the deeper you go, if you take a core of ice and the deeper you go, the bottom ice is reflecting a time when it was deposited, which was maybe 100,000 years back. And the top ice is basically reflecting the current deposition, the current condensation of water into snow. Now, when ice forms like this, air bubbles are preserved in the ice, right? So when water vapor condenses and falls as snow, and the snow basically compacts and creates ice, the air bubbles are trapped inside that ice. These air bubbles contain the amounts of greenhouse gases that were present at that period of time. So an ice section that has formed, let's say, 1 million years back, will contain a 1 million-year-old air bubble that will contain the amount of CO2 that was there in the atmosphere 1 million years back. So if you take an ice core, you cut it up into sections according to its ages, and then you extract these air bubbles from them, and then you analyze the carbon dioxide that is present in that air bubble, you will know how much carbon dioxide was there 1 million years back. Okay, so this is what is done. So this is how it's done. So here you see a person is sort of digging a hole, a cylindrical hole through the ice sheet, and they get something like this. It's a cylindrical core of ice. So if you cut the sections like this, the ice core sections like this, assume that this is the top part of the ice and this is the bottom part of the ice. So this bottom part will basically include ice that was formed millions of years ago. This one, a slightly younger ice. This one, a slightly younger ice. And this one is the most modern current ice. So the air bubbles trapped here would represent the carbon dioxide and methane and other greenhouse gas concentrations that are currently present in the atmosphere. This one would represent carbon dioxide concentrations that were present 1 million years back. Okay, so this is how you can reconstruct the profiles of greenhouse gases going back thousands and hundreds and thousands of years. Okay. So that is one aspect of greenhouse gases. How do we know what the temperature was 1 million years back? So in order to understand temperature, we take help of what are known as isotopes. So isotopes are these chemical forms where you have the same number of protons and electrons, but different number of neutrons. So the masses are different for the different isotopes. So as you know, hydrogen has these 3 isotopes. One is the normal hydrogen, the other one is the heavy hydrogen. There is another, a heavier form of hydrogen. So depending upon the difference in mass of these isotopes, there will be a relative distribution among the composition of these various isotopes depending upon the temperature. So if the temperatures are low, we will find a certain fraction of one isotope as compared to the other. When the temperature is high, we will find a certain other fraction of one isotope as compared to the other. So when this ice is forming, when the sediments are forming in remote lakes and oceans, then the composition of the isotopes depends on the temperature of the time when it was formed. So if you sort of extract these ice cores and sediment cores from the lakes, you estimate their age and you measure the isotopes, then there are mathematical relationships that tells us that if this is the isotopic composition, this must have been the temperature. This relationship, this equation is very, very robust. This has been dissected and proved numerous times across the world. We have a very robust equation that tells us if the isotopic composition is this must have been the temperature during that period of time. So using these proxies, we call these proxies, using these proxies, we can reconstruct temperature and greenhouse gas profiles for nearly 1 million years before present. Okay. Now, what does this reconstructed history tell us? What is the history of climate of the Earth? Now, the photos that I showed in the last slide, so they are ice cores that are probably 4 or 5 feet long, and they will probably go, let's say, couple of hundred years before present. So they will tell us the history of, let's say, the past 200 years. In order to know the history of a 1 million year period, we have to have much longer cores. So the largest core that has been collected so far in the world is a 3 kilometer long core. So imagine that cylindrical tube of ice. Imagine a 3 kilometer long tube of ice that has been collected from Antarctica. Okay, so this provides almost an 800,000 year record. It's almost a 1 million year record of temperature and greenhouse gas concentrations. So now we know how temperatures have changed in the Earth for the past 1 million years, how greenhouse gas concentrations have changed in the Earth over the past 1 million years. So the figures are like this. You have time going backwards. So 0 is the current period, and we are going back 800,000 years in time. So the black line is the temperature, the green line is the methane concentration, the red line is the carbon dioxide concentration. So what do we see from here? We see that there are periodic fluctuations. See, there is absolutely periodic, predictable fluctuations in carbon dioxide, similar periodic fluctuations in methane, and exactly similar fluctuations in temperature. So what we can conclude is, number one, there have been natural fluctuations in climate over the past 1 million years. It's a natural process. But what makes the current period different from what has happened in the past 800,000 years is that the current levels of CO2 are somewhere here. It's going beyond the scale. So if you zoom in here, this is what it looks like. It is 380 in this plot. The current value is 413. So it's beyond here. It's somewhere here. So the point is that over this 800,000 year period history, the carbon dioxide concentration has never been more than 290 parts per million air molecules. So this value has never gone beyond 290. The current value is 413. So no natural factor can explain this huge rise in CO2. It's only the anthropogenic component that can explain this. The second thing is, this record, as you can see, also shows periods of warmer climate and colder climate, fluctuations, periodic fluctuations. They happen every 40,000 years to every 100,000 years. Okay. So these are what are known as glacial cycles and interglacial cycles. So we are currently in an interglacial cycle, meaning in our Earth at this point, the ice is concentrated only near the poles. There is no ice apart from high mountains. There is no surface level ice anywhere. During glacial periods, when the temperatures dipped, then ice sheets were covering almost till subtropical regions. Okay, so subtropical regions, 45 degrees, 60 degree, around that period of that latitude, these were covered in ice. So these are glacial regions. So why are these natural fluctuations happening? Natural fluctuations are happening simply because of the way the Earth revolves around the sun. So these are called Milankovic cycles. We know that the Earth revolves around the sun in a slightly elliptical orbit like this. It's not a circular orbit like this, it's an elliptical orbit. Now, how elliptical this orbit is itself changes with time. Sometimes the orbit becomes a little more elongated, sometimes it becomes a little less elongated. So let's say if the orbit becomes more elongated like this, and the Earth is here, it would have greater amount of sunlight as compared to this condition where the Earth is further away from the sun. So this is a periodic change in the amount of sunlight that the Earth receives. Okay, so this creates these natural fluctuations. There are two other things also. We know that the Earth is not standing straight up like this, it is tilted, right? So if you draw a line from the South Pole to the North Pole, the Earth is not standing upright like this, it is tilted in this direction. So it's like this. So this is the vertical and this is the tilt. Now this current tilt is about 23.5 degrees. The thing is that this tilt is not constant. This tilt fluctuates like this. Okay, it fluctuates between 22.1 and 24.5 degrees. It's continuously fluctuating like this. So what it does is that as it fluctuates, the amount of sunlight changes, that it hits different parts of the Earth. If it tilts away from the sun, then less sunlight hits. If it tilts towards the sun, more sunlight hits. Okay, so this also has a periodicity. This tilt change happens over periodic cycles. The last thing is, the Earth as tilted does not point towards the same direction. The direction also changes like this. If you put a top, right? The tops that, I mean, we used to play during our childhoods, if you put a spinning top, you will find that it bobbles like this. It moves like this. So this is called precession. So a good example of this is that we know that you can look towards the north and you can find the North Star. So the current North Star is Polaris, but the North Star is not constant. The position of the Earth is changing. So the direction that it's pointing to is continuously changing. As a result, Polaris is currently the North Star. 3,000 years back, when, for example, the pyramids were being built, Polaris was not the North Star. A completely different star, Alpha Draconis, was the North Star because the Earth was pointing in a different direction at that point of time. Okay. So these periodic changes in the way the Earth revolves around the sun, that induces these natural fluctuations. So these are the causes of these changes in carbon dioxide, methane, and temperature. These are the natural causes of climate change. However, this part, the part where we have a very sharp increase in temperature, sharp increase in carbon dioxide, this is entirely anthropogenic. Now, how do we find that this is anthropogenic? We find it by using models. So what the models do is that the models try to predict past temperatures, and when they become good at predicting past temperatures, then we use them to predict future temperatures, right? So that is how they're evaluated. And a model will typically have two components. It will basically have a natural component. So all those fluctuations that I discussed just now, they will be included in the model. The variability in the sun's output, any volcanic eruptions that might happen, all of these components will be included in the model. And it will have a separate anthropogenic component where all the coal burning, all the diesel, gasoline use, the emissions from that, they will be included. So if you do that, then we find that the models predict that the temperature will increase in this manner. This blue thing is the prediction, and the black thing is the actual measurement. So you can see that the blue line and the black line, they follow each other. They match up quite well. So the models are good at predicting now. Now, in order to understand what is the importance of the anthropogenic component, the human component, what we can do is we can simply switch off this in the model. We can ask the model that, okay, now you run with only the natural component, forget about the anthropogenic component and see what output comes. So if you do that, if you remove the anthropogenic component from the model, then the model will simply replicate or give the output of what the natural factors would do. So if that is done, then we find something like this. So with the anthropogenic part removed, the model predictions go like this. So it actually talks about a decline in the warming. However, measurements show that temperatures are increasing. So where is this difference coming from? This difference is the human-induced component of the climate change. Whatever prediction is there for the natural component, when that is subtracted from the measurement, that difference is the amount of climate change that is being caused by human activities. Okay. So then, if you look at global temperature change, it looks something like this over time. So we are starting from the late 1880s, and yellowish colors or reddish colors are warmer climates and blue colors are colder climates. You see that over time how the prevalence of yellow and red are increasing. So this is about 1950s now. In the 1960s and 70s, the climate cooled down a bit. But after the 80s, see what happens. So how the prevalence of the red increases. So this is the current state now. And this, as you could see, this has started mostly after the 1960s and 70s, and it has continued to a very significant degree. Lastly, who is to blame for this? Who do we blame for this anthropogenic climate change? Now, if you look at how emissions of CO2 have changed from different countries over time, we find something like this. The United States used to produce a lot of CO2. Now the levels are going down. Europe used to produce a lot of CO2. Now the levels are going down. So historically speaking, US, Europe, and Russia were the largest producers of carbon dioxide because they were rapidly developing after this industrial revolution. Now it is China and India. So China emissions, you see here, this line, and the Indian emissions are this line here. So these are the major drivers. So if we are to put blame on a country, then we cannot put blame on one single country. We have to talk about which countries have historically emitted more CO2 and which countries are currently emitting more CO2. These two countries, the sets of countries are different. Therefore, the responsibility has to go to both. So in terms of mitigating climate change, we have common responsibility, but differentiated responsibility. The responsibility is common to all of us, but it's differentiated. The United States cannot say that right now I'm producing less and therefore I will not take any responsibility, because they have already produced a lot. And the climate change that we are facing is because of this production. Right? Similarly, India cannot say that I have not produced anything in the past, so now you have to allow me to emit a huge amount. That is also not a reasonable thing to say. So we have to have common but differentiated responsibility. So in terms of absolute amounts of emission of CO2, you have that Russia, US, and Europe were the largest emitters historically. China and India are the largest emitters currently. But if you look at it on a per capita basis, meaning if you divide the total emission by the total population, and if you try to find out how much one person on average is emitting in these countries, we see a very different thing. We see that US has a huge per capita emission, 16 tons of CO2 per capita, per person in the US. Compare it to the developing countries, China, India. So even though our total emissions are high because of large population, the per person emission in China and India is very low. It's 7 tons in China and it's almost 2 tons in India. So it's about factor of 8 lower than that is there in the US. So while the US is emitting less, it is being more emission intensive. Per person emits a huge amount of CO2 from wasteful activities as compared to a person who is living in China or India. Okay, so this is how we sort of should try and look at when we are talking about fixing responsibilities for climate change. So lastly, to conclude, we had asked a few questions during this brief discussion. So first thing is that we have talked about that is climate change happening and how do we know for sure whether climate change is happening? So the answer is yes, climate change is happening. There is significant measurement evidence, temperature measurements from thousands of thermometers located across the world with no conspiracy between them. They independently show that global average temperatures are going up, coupled with models that tell us that global average temperatures will go up. We have reconstructed past climate based on isotopic records from ice cores and etc. that have told us that the current temperatures are unprecedented on timescales of millions of years. This has not happened in a million years. What we are seeing is the happening for the first time in 1 million years. Are humans responsible? Yes, overwhelmingly responsible. The measurements have been carried out in the Industrial Revolution, and the model simulation, as I discussed, clearly point out that the humans are mostly responsible. How important are natural factors in driving climate change? They are quite important, especially when we talk about periodic fluctuations, small fluctuations over geologic timescales, meaning millions of years. Over million-year timescales, these periodic fluctuations are significant, but the magnitude of the current climate change cannot be explained by natural factors alone. This is significant, that there are natural sources, but the magnitude of the current climate change cannot be explained only by natural factors. You have to go back to the human activities part. Which countries are responsible? All countries are responsible, but to different degrees. Historically, US, Europe, and Russia have contributed the most. Currently, China and India have taken over. So all countries are responsible to different degrees, and therefore the load of responsibility that we should share in terms of mitigating climate change should be common to all countries, but with differentiation based on our actions of the past and actions of the present. Okay. So this is where I stop here. Thank you for your time. Thank you to all the students for kindly attending. If you have any questions, I'll be more than happy to answer. Thank you.
Thank you so much, Dr. Sarkar. This has been an absolute pleasure, a fascinating session listening to you. Thank you for bursting a lot of myths and for illuminating our minds with thoughts that would keep us meditating, that would keep us, quite in the loop, asking so many questions, which I myself, I am absolutely struck, and it would take time for me to sink in. We are going to begin an interactive session with you, and to conduct this interactive session, I request our lead technical support, Dr. Rajashri Dasgupta, to take over. Dr. Dasgupta has been instrumental in setting up this webinar technologically, along with her team members, Professor Abdul Mateen Wasim, and our office staff, Mr. Arup Ghosh. There is yet another aspect of Dr. Dasgupta which I must say over here. Apart from being a great scholar in her own field, she heads the Department of Geography and looks after a lot of issues in our college. Whenever we are stuck, there's one person, it's a kind of a go-to person, that is our very dear Rajashri, and she solves a lot of things for us. So thank you, Rajashri, for helping us, and would request you to conduct the interactive session. I'll take just a couple of seconds and ask the viewers to kindly post their questions. There are already some questions that have come in. I would request them not to unmute and ask our resource person directly, but to go through Dr. Dasgupta so that we can conduct this session and then move over. Over to you, Rajashri.
Thank you, Antura. Am I audible to all?
Yes, Rajashri.
Okay. Thank you, Dr. Sarkar, for such an engrossing session, and it enlightened us all, and you have in a very simplified manner, you have described all the needs and all the major issues related to this climate change. It is really difficult to cover all these aspects and issues of this vast topic within this 30 to 40 minute session. Plus, really, you have given us a very wonderful session and wonderful deliberations, very simple presentation, but yet very understandable. Thank you, sir. Now, we have got some queries regarding this topic from our participants. So, our coordinator, IQSC coordinator, sir, he has put one question from this Dr. Debu Prashad Banerjee. He has asked that we have heard about the wobbling of the moon and the entire earth will be underwater. So what is your opinion? What is your observation regarding this?
Yeah, so I mean, I think it's unlikely that the earth will entirely be covered in water because of the wobbling of the moon. Generally what happens is that all these planetary bodies, the earth, sun, the moon, the other large planets that are there in the solar system, all of them exert gravitational influence on the other. And this gravitational influence is the basic reason why these orbits fluctuate, why the earth precesses, why it wobbles. So it's basically ultimately has to do with the gravitational pull of one planet over the other. So the earth and the moon are entered into this tight cycle that they have. So the moon exerts its influence on the earth and the earth exerts a similar influence on the moon. I think it's highly unlikely. I mean, I am not aware of any evidence or simulation as such that tells us that the wobbling that is created essentially by the gravitational interaction will lead to such a catastrophic condition that the entire earth would be flooded. So while the condition exists, yes, there is wobbling of the earth, there is a wobbling of the moon, but I would not think that it's too catastrophic in that sense to create such a large damage.
Okay, thank you, Dr. Sarkar. Thank you.
Yeah.
Please unmute yourself, Rajashridi.
Yes, am I audible again?
Yes, you are.
Okay, so the second question has been put by Mr. Ronnie Troy. He is asking that how far is anthropocentric behavior akin to planetary force is changing the climate of the planet? And the second question, that is the second section of his same question, is what responsibility the social scientists can share to create awareness in the form of research in this regard?
Yes. So I can't claim any expertise in answering the second part of the question. That is completely out of my field. For the first part of the question, okay, so I think the last couple of slides I've talked about is entirely focusing on the anthropogenic component. The term that you have used, anthropocentric behavior, that's a nice term. That is actually what is happening. If you actually look at the Earth's geological history, we can divide it into various periods and epochs and eras. So the current epoch that we are in is called Holocene, about 11,500 years back. Now there's a growing consensus among scientists in order to identify the period starting from the 1950s as a separate geological period altogether called the Anthropocene. So humans have sort of affected the Earth in such a large such a large degree that it now merits a geological age by itself. So it's called the Anthropocene. The period beyond 1950s is called the Great Acceleration. So yes, human activities have changed the planet irreversibly. What I did not understand in the question is that how far is anthropocentric behavior akin to planetary force? So I don't understand what exactly you mean by planetary force. Ronit, if you can clarify.
Yeah, can I please?
Sure, you can interact with him directly, our resource person directly, no problem.
Okay, so Professor, my question is the planetary forces, for example, in a very basic example, if you consider that the hitting of an asteroid or any kind of planetary force which changes the Earth to a great extent.
Okay, understood.
And now the anthropocentric behavior, perhaps it is changing the Earth for, say, in a very short period of time, in a condensed time for the next 1,000 years. So can those two be compared?
Yes. So I understand your points, and you have sort of yourself answered your question. So the major difference between a planetary force, as you define it, and the climate change that is caused by human activities is the time scale. So human activities have been affecting the planet for, let's say, the last 150 years. And the results are going to be felt in the next 100, 200 years. An asteroid hitting a planet would be a momentary thing. but the devastation that generally caused, depending upon the size of the asteroid, of course, the devastation that would cause would be immediate and highly catastrophic. I mean, if you consider a very large asteroid, I mean, we have histories where entire populations have been wiped out by large asteroids. Dinosaurs, for example, entirely wiped out by large asteroids. Climate takes huge amounts of time to recover from these things. For example, if a large asteroid hits, the first, I mean, if you even forget about the explosion and the heat generated and all that stuff, the fires, the other thing that it does is that it will send bits of rock and soil into the atmosphere. And if that bits of rock and soil stay in the atmosphere, they will block sunlight. So you will have perpetual winters for centuries after an asteroid hits like that. So that, I mean, if you are considering about a large asteroid, that would be catastrophic damage. So we are not at that stage yet where that sort of catastrophic damage can be experienced by anthropogenic climate change. But it's a slow poison that is sort of working. That would be my answer.
So the third query is from Obhigyan Guho. He is asking that what might be the ideal pathway for India's climate diplomacy in tandem with ensuring post-pandemic green recovery in fidelity with the 2030 SDG agenda.
Okay, so this is a question that would probably take like a course, an entire one semester course to answer. There are many things here. So for example, climate diplomacy is here, pathways of development, post-pandemic green recovery, and 2030 SDGs. Okay, so first with the 2030 SDGs, there are certain things, action plans that are defined under the climate action plan of the 2030 Agenda for Sustainable Development. India is a party to all major climate treaties and associated ones. For example, Montreal Protocol, the Kyoto Protocol, Paris Agreement, the other offshoot of the Montreal Protocol that talks about HFCs. India is party to all of that. And being a party to all of that, India needs to develop a greenhouse gas mitigation policy and submit it to the UN and other monitoring agencies yearly for approval. And India does that. So India has actually done quite well in terms of greenhouse gas mitigation and sort of policy regarding that. Unlike large countries and irresponsible countries such as the US, who can simply come out of a Paris Agreement on the whim of a president, India has not done anything erratic like that. So we have been following the policies, and we have actually developed a very good greenhouse gas emission inventory. So it's developed by the Ministry of Environment, Forests and Climate Change with a number of agencies across India. It's a comprehensive greenhouse gas emission inventory that India has developed. India is also developing its own climate model, because till this point of time, we had to rely on the other climate models, the global climate models, let's say developed by NASA or NOAA or other organizations. But these models are not tuned towards Indian conditions, right? So India, for example, this IITM Pune, Indian Institute of Tropical Meteorology, Pune, so they have developed a climate model that is fine-tuned for India. So in terms of India's progress, in terms of science and research on climate change, it's a very, very good progress, I would say. Now, climate diplomacy also, I think India is quite good at it. We have committed a lot in terms of reducing emissions, future reduction of emissions, while at the same time being firm at the point that we will only reduce emission intensity, not total emission. This is very important, because, I mean, we cannot say that we will stop development and stop all greenhouse gas emissions from now on. That is not possible. We are a developing country. We have to develop. So what we can do is we can make our industrial processes more efficient, so that the amount of energy released, or the amount of CO2 released per unit production of energy, that goes down. So we make the process more efficient. So India has been quite smart in terms of focusing that we will improve our energy use efficiency, not the total emission. So this is very important. Post-pandemic green recovery is something, again, that I have no expertise in. Generally, when you consider climate models, there are various scenarios that are given. These are socio-economic scenarios. So if we are to, let's say, limit world temperature to 2 degrees or 1.5 degrees, then there are multiple socioeconomic pathways that are available that can help us to reach that goal. So these are well-developed emission pathways, well-developed population scenarios, well-developed political conditions, well-developed economic growth conditions. The one that India might take in the future, I cannot predict at this moment. But for the remaining part of your question, that would be my answer.
Thank you, sir. One question is coming in my mind. So can I put it to you?
Yes, sure.
Sir, only 2 days back, I have read one news that the Copernicus Atmospheric Monitoring Service that is reporting that the ozone hole is gradually increasing its size. But only few years back, NASA has reported something else. So why such contrasting views are coming regarding this?
So, I know the report that you're referring to. So this is regarding the Antarctic ozone hole that is over the southern hemisphere. So that has now increased this year to exceed the size of Antarctica. Yeah. So the thing with the ozone hole is that the ozone hole is one environmental problem which is mostly solved. So it was a problem that was created by these chemicals that were developed in the 1940s. Problem was identified in the 1970s and 80s. Montreal Protocol came into existence in the 1989. And the problem has more or less been solved, though the ozone layer is sort of well on its recovery. So in, let's say, 2030, 2040, the general amount of ozone in the stratosphere should recover back to 1980 levels. So that sort of recovery we are expecting. Antarctic ozone hole is far more severe, so the recovery will take a little bit more time. So maybe 2060, 2080, it would recover. But the point is that there are periodic fluctuations in the amount of ozone hole that is produced over Antarctica from year to year. Some year it's small, some year it's large. This year is exceptionally large. One possible reason is that, as per the Montreal Protocol, there are certain substances which are banned, the chlorofluorocarbons, which are banned. They cannot be used by governments from the late 1990s. But recent evidence has come out that there are certain regions in China, for example, that are illegally using CFCs. So these chemicals that destroy ozone were banned and they were not used for the last 15 years, but now they have been started to use again. So that is one potential cause of concern, that if people illegally use these materials, then it will cause again massive destruction of ozone.
Okay, sir. So another question from my student side, that is why the intensity of the high intensity events, why the frequency of this high intensity events like this, cyclones, tsunamis, submergence, all are increasing, mainly in the Bay of Bengal coast. And though it is also rising in the Arabian coast, but every year we are facing the same problem. Is it something to do with the sea surface temperature rise?
Yes. So any sort of storm system that forms over oceans is a function of sea surface temperature. One of the hallmarks of climate change is that it leads to increase in extreme conditions. That is one of the main characteristics, that warm days become more warm. Rainfall events either become extremely severe or dry up completely. So either you have flooding or you have droughts. You do not have anything moderate in between. So climate change has this tendency of like extending the extremes in both directions. I mean, one valid explanation for the frequency of storms is that if you have more sea surface temperature as a result of climate change, greater evaporation is there, and any storm system is driven by this moisture transport from the sea surface. So greater evaporation from the surface means that greater amount of energy is being transported from the oceans to the atmosphere, and the storm basically feeds off that energy. So the greater the amount of temperature rise, greater will be the warming of the ocean surface, greater will be the amount of evaporation in order to feed a storm, and also the moist convective energy, what is known as moist convective energy, that will also be transferred to the atmosphere, leads to more intense storms, more prevalent storms. So this is a direct consequence of climate change. Global warming, yeah, apparently.
Okay, thank you, sir. This is up to now. These are the questions only. So thank you, sir, for patiently hearing us all and answering to all our queries.
My pleasure.
I have a question.
Our dear TCS madam, she is asking that can you please share with us some experience of yours on North Pole? So will your time?
Yeah.
Okay, I have
I'm waiting for
few photographs that I can show you, and I can just give you a narrative of what the things were.
So you'd love to hear.
Can you share?
Yeah. I have a few photographs that I can share. So, okay. So is this visible now?
Yeah.
Yes, sir. It's coming.
Yeah. So the thing is that India actually has a presence in the Arctic region since 2008. India has had a station there since 2008. It maintains a research base called Himadri. The place is called Nyalesund. So Nyalesund is at 79 degrees north. So that is the northernmost human settlement. So there are no places where people live beyond 79 degrees north. So this is part of Norwegian Arctic. India maintains a research base there, and there are various areas in which scientists conduct research in the Arctic going from India. So one is the productivity of the phytoplanktons in the Arctic Ocean. One is retreat of glaciers, of course. Biodiversity is one. Microbes, terrestrial, bacterial communities in various Arctic ecosystems. Optical properties of aerosols. How do aerosols absorb light in the Arctic atmosphere? And how are aerosols coming to the Arctic? From where are they coming to the Arctic? How are they being transported to the Arctic, and how are they affecting the climate? So this is something that our research group has been doing. We actually, the National Center for Polar and Ocean Research, which comes under the Ministry of Earth Sciences, its headquarters is in Goa. So this organization coordinates all the Arctic and the Antarctic expeditions from India. So, I mean, we have a project funded by them where we try to go there periodically once every year and make measurements there. So this is basically, this is the research village at this Nyalesund. This is the Arctic Research Station. This would be the Arctic Ocean. And these houses are, each house is for each country. So there are about 10 or 11 countries here. So India is there, China, Japan, Korea, Germany, Russia, UK, and many countries are there. So these are, each house belongs to a country, and the researchers go and stay there on a periodic cycle, and we conduct research on various aspects. So the Indian house is this one. I have a separate picture showing, but the Indian house is this one. This is actually the central canteen and the mess where we have to go and eat. This is China's building. See the size of this building as compared to the Indian building here.
Excellent.
This is China, and this is Korea here. So this is the Indian Arctic Station, Himadri. So this is the station. It's a one-story house. It can accommodate 8 people at the same time. So at any given point of time, only 8 scientists can be there. It's a sharing basis, 4 rooms, and we have a small-scale lab there, a couple of small-scale labs, and a computer room and stuff like that. So this is the Himadri station. This is a lab outside the village where we have all the equipment kept, the measurement is done. So this is called Gruvobadet lab. So this is from the rooftop of the Gruvobadet lab. These are some of the equipment that are used. So we collect these aerosol samples, these tiny dust particles, and then we analyze and see where they have come from and what are the effects. And this is what a typical day would be like. So we would basically need to walk or take a bicycle and then ride about 2.5 kilometers outside the village and come to this lab and go to the rooftop and collect the samples.
Okay.
So, yeah.
It's wonderful.
So these would be the glaciers. So the nice thing is that if you look 360 degree around, there are about 12 or 13 glaciers that come and feed into the Arctic Ocean there. Going from Calcutta to that place takes 5 flights. So Calcutta does not have any direct flight international. So you have to go to either Delhi or Bombay. So from Delhi or Bombay, you go to Frankfurt, then to Oslo, then to a place called Longyearbyen. And from Longyearbyen, you have to charter a flight there. So this is a very small flight, holds only 12 people. So this flight can take you directly there. So this is a glacier en route to Nyalesund. So this is the the mouth of the glacier. This is where it ends, and this is where it drains into the Arctic Ocean. Whenever somebody goes out of the research village, there are polar bears around, and polar bears are dangerous animals, so there has to be rifle training. So every one of us is given rifle training. These are very high-powered rifles. And we are given rifle training. We have to undergo a test, like shooting test, and then we are given certificates like this if you pass the test. So unless you pass the test, you cannot go out of the village, because there are polar bears.
We'll have to organize another lecture for it.
That's right.
Yeah. So this is a boat that takes us, the people who do Arctic Ocean research, the boat takes them. This is a photo from the boat. This is a stuffed polar bear that they have in the mess hall. This thing is actually much taller than me. So I'm 5'10", and this stands at about 6'3", 6'4". This is huge height. And this is an Arctic fox, so that sometimes roams around. So yeah, so this is what I basically have. It's a very nice experience. I mean, we go there and we stay there for about a month, a little more than a month. There is no, mobiles do not work there. So for a month we are no mobile. So
Sir,
yeah.
we have
It's a fantastic
two more
experience, actually.
questions in our chat box which has come just now. So our professor, Dr. Joyantojoy Chattopadhyay, he is from HOD of Political Science Department. He is asking that the political elite of Brazil has recently destroyed a part of the rainforest. So what has to be done with this?
Yeah, this is a very relevant and pertinent thing, and what is being done in the Amazon currently is like, it's sad. I mean, the Amazon has these forest fires every year that happen because parts of the Amazon are being cut down to produce sugarcane, and Brazil is very well known in terms of production of biodiesel, and this biodiesel comes from sugarcane. So they are basically cutting down forests to create agricultural land in order to improve the economy. And by doing that, they're destroying the rainforest entirely. So, I mean, I can only talk about the climate effects of this. The problem that is happening is that Amazon used to be a sink for pollutants, because as the trees grow, they absorb carbon dioxide. So they are taking the excess carbon dioxide from the atmosphere and storing them inside their body. So Amazon used to be a sink. Now Amazon has become a source. So, I mean, so much trees are being cut down and burnt that the carbon that was stored inside is now being released into the atmosphere. So instead of taking carbon from the atmosphere, the Amazon is now adding carbon to the atmosphere. So instead of a sink, it has become a source. So it's a tremendously bad problem.
Okay, so last question from Payal Ghosh. She is a participant from YouTube.
Yes.
So she is putting the question that the policy of scrapping the old vehicles and starting the electric vehicles have started, and it is planned from 2030. So will it help to mitigate the climate efforts, climate change efforts?
That's a good question. I mean, there is a nuance associated with that question. So scrapping of old vehicles is done generally not to produce less greenhouse gases, but to produce less air pollution, because these old vehicles will produce the carbon monoxide, oxides of nitrogen, oxides of sulfur, these dust particles, the black carbon soot particles, and they will have effects on the human health. So phase out of old vehicles mostly helps in reduction of air quality. Now, I mean, betterment of air quality. If you convert the diesel and the petrol vehicles to electricity-driven vehicles, then of course you are burning less diesel, less petrol, and you're emitting less carbon dioxide. But we have to be careful about where this electricity is coming from. If the electricity comes from a power plant, then there is no point in doing it. Because if you're replacing petrol and diesel by burning coal in a power plant and taking that electricity and putting it into a vehicle, you are still releasing carbon dioxide from that power plant. So electric vehicles work in terms of climate only when the source of the electricity is not power plant, coal-fired power plant. The source of the electricity can be something else. It can be natural gas. It can be, let's say, hydrogen fuel. It can be anything else. You can use any sort of clean fuel to produce the electricity, and then use it in the cars, only then will it be sustainable. If you are burning coal in a power plant and producing electricity and running electric vehicles, that is not going to, you're just transferring the pollution somewhere else. Yeah.
Okay, thank you, sir.
Yeah.
That's all from our part. Thank you. So
Okay.
over to Antara Mukherjee now.
Thank you, Rajashree. Thank you so much. I still find some very encouraging words in the chat box. Some good things coming in from students. We are blessed to have students from other colleges. Shreya Mukherjee, for example, from Hooghly Mohsin College. And she says that this webinar is wonderful, interesting, and informative. Thank you so much. We have also a feedback from Dr. Deepa Bhattacharya. She says that excellent experience of Himadri, wonderful. And she is thanking the college authority for arranging this webinar. We have also an encouraging message from Shohini Bhattacharya, who says that this webinar is very informative and interesting. So thank you for your comments, for your questions, and for your enquiries. Now we have come to virtually the end part of this webinar. This may be the end, but this could give rise to another beginning, right? So let me start this final vote of thanks by thanking all those who have cooperated with me over the last 10 days or so, have slogged with me and have supported me, of course, in organizing this event. I start by thanking our principal, Dr. Al-Qadri, who never says no to any kind of academic or co-curricular endeavors that we, in this new institution, our college is just 5 years old. This is a new college that has come up in the vicinity of Khidirpur, Mominpur area. But we are trying as faculty members, as office staff, as casual staff, all of us are trying to do something so that this college could run smoothly under the able leadership of our principal. My regards are also my gratitude to the entire IQSE, from the coordinator to the members, our TCS, and of course our college office headed by Mr. Pratul Chakraborty, and also my technical team over here, headed by Dr. Rajashree Rajgupta, Professor Abdul Mateen Wasim, and Mr. Arup Ghosh. We all know what Arup has done. I just want to tell the viewers that this live telecast on YouTube channel, Google Meet and everything has been arranged very meticulously by him, and we owe him a lot. So this team that has been working is also consisting of my committee members, Dr. Koel Odhikari, who is battling a family problem today. She couldn't be with us physically, but she is there virtually. She has been my pillar of strength from preparing the flyer to everything, the editing the video. Koel has been a strength in the true sense of the term. Dr. Shabnam Parveen, with all her difficulties, she is there with us. And of course, my co-convener, Dr. Mumu Chakraborty, who is also a part of this committee, and she has been a supportive friend, a colleague. I also want to thank our resource person. Of course, no words would suffice. I want to thank participants from other institutions, my students. I'm sure you have been enriched. The way this talk was, delivered in a very erudite yet student-friendly way. I'm sure it has reached our students. And last but not least, I would also like to thank each and everyone, if I have missed out in this vote of thanks, the mistake is mine, the fault is mine, but the credit is all yours. So thank you once again for the support. I'll end today by saying that we are sharing the feedback link here in Google Meet. I'll request Professor Abdul Mateen Wasim to share the feedback link in the chat box, and would request each and everyone present over here to submit the feedback link. E-certificates will be generated, but the process, as I said, may take a day or two, because in a day, only 100 certificates could be generated. So please bear with us. You will receive your e-certificates, and we are sharing the e-certificates both here and in the YouTube link. I shall be sharing in the YouTube link once I finish addressing all of you formally. So thank you once again. Thank you, especially my coordinator, IQSE, and PCS, and our resource person. Thank you.
Thank you all. Antura, have you taken photograph?
Yes,
You can tell all of them to put on the camera.
Yes, of course. If I'll just take I'll just take 10 seconds and share the link in the YouTube. Then I'm coming back. Please bear with me.
Just a minute.
I'm so happy that Professor Abdul Mateen Wasim has shared my labor once again. I could not have done anything without this team. Thank you so much. Dr. Sharkar, I'm sure it's just the beginning, and
Yes,
we are going to hear from you in the future as well.
Thank you so much for
Request participants and our students and members to please switch on their camera, and so that we can have some moment captured for us.
Dr. Sharkar, we would like to hear about your experience of North Pole in detail.
Yeah. We'll arrange another lecture for you.
Yeah,
absolutely.
Fantastic.
For that. Yeah.
And your lecture is fantastic. Thanks a lot. Thanks a lot.
Yeah, this was a unique experience for us. Staying at our home, we could glimpse pictures from far off land. That was something great during this pandemic situation.
Yes, we are actually very blessed, because all the accolades that we are getting, there's been tremendous accolades coming in from the YouTube. Let me just, it would be unfair if I don't read out few. Mumu Chakraborty has joined the YouTube. As I said, she's my joint convener in the seminar subcommittee. She's wishing all of us. Dr. Anupriya Chatterjee says, thank you for this wonderful and educative session. It was a great learning experience. Madhumita Ghosh is saying, thank you for arranging such a wonderful and informative webinar. So it's all because of you, Dr. Sharkar, that we are being, we are tasting the fruits of your academic research. Actually.
Here, as a absolutely informal information, I just want to mention the name of Dr. Sharkar's father, Piyush Sharkar. Actually, Piyushta is very close to me, very close to us. That's why I got connected with Shayantan, and I'll thank Piyushta for that. In fact,
Yeah.
Yes, thank you, Shampadi, for arranging this talk. For contacting with Dr. Sharkar and making this possible. So that is also something which as a convener, I must acknowledge in the open, and I'm sorry that I had this happens. You don't seem to take into consideration your family members. So this GGDC family is like that.
Yeah, of course. So
I'm so happy to see Joyantoda here, who has been
absolutely. Joyantoda is here.
Joyantoda without cigarette is
yeah.
It's very
That's
nice.
why I asked him that you please put your camera off. Joyantoda pardon here.
Okay.
So it's over.
Okay. Yeah.
Yes.
Okay. So
Okay,
I'll
thank you all. Thank you all. Thank you,
all.
Sarsha.
Thank you.
Thank you.
Yes, Dr.
Thank you for your time. Thank you.
I'm
Bye.
giving a clap for
Yeah.
you.
Thank you. Thank you. Bye. Yeah.
Thank you, ma'am.
Thank you.
Thank you, sir. Thank you, all
Yeah,
the
thank you.
teachers.